Okay, folks. Seems like we're up and running. Time check 2:30. Let's begin. My name is Furmanek. Thank you for coming to this talk after lunch. Hopefully you are now full of power and you are here to learn a couple stuff about database guardrails. So what we are going to discuss for the next 20 minutes is we are going to see how the world has changed for the last 2 decades. We are going to understand how the complexity of our applications increased and how we need to adapt to the new environment, to new circumstances, no matter whether we are small startups or if we are like Fortune 500 big company, no matter whether we are dealing with like microservices or monoliths, we need to change the way we work just because the world has changed. Let's see what actually happened. Before moving on, a couple words about me. I'm working as DevRel at Metis, and what we are doing is we are doing database guardrails to deal with the complexity of databases and to make sure that you do not deploy faulty code to production. So if you ever observed issues with like your SQL query performance or whatever else, then bear with me, we're going to see how to tackle that. So where we used to be 10 years ago, 15 years ago, 20 years ago, it was always simpler. So what we had is generally when we were working on applications, it was rather straightforward, right? There was one SQL database, maybe a couple of nodes like on EC2 or whatever else, because we were on-prem back then, some load balancer and obviously user calling, all of that stuff, right? Easy as that. If we wanted to deploy something new, build new application, it was way big journey because we had to basically replicate all of that and create on the site, right? That was the idea how it used to work. And when there was an issue with performance, what we were doing is we had a team of DBAs, or we generally had someone who was proficient enough with databases. They could step in, understand what was going on, understand the performance of the database, and kind of deal with it, right? That was easy. We as developers, we could generally focus on doing the software, then we are obviously throwing it over the fence to some like sysop managers or whatever else, they were deploying that. Generally, this is how it worked. However, things have changed significantly since then. Now, when we are talking about the complexity, we are talking about serious stuff that changes every single day. So we are not dealing with one code like base anymore. We are now in the world of microservices, so we have like serverless solutions, we have lambdas, we have event triggers, we have things that are reactive and generally they work constantly. We also, when it comes to databases, we have many more of them. Each microservice has its own database. It can be SQL, NoSQL, data warehouse, some fancy solutions for storing data at the edge, etc., etc. Generally, those things are now much more complex. What's more, everything talks with everything. So when we are talking about the intercommunication, now all microservices, they speak with each other, right? We have the stuff that is constantly being sent over the network. And now let's think about that. Okay, we deploy stuff many times a day. They tell us, hey, let's deploy on Friday afternoon, right? We deploy, we deal with the complexity, we have infrastructure as code, we create CloudFormation change sets in AWS. And what happens when something breaks? When something goes wrong, we don't even know where to look for an answer, right? Because logs are scattered around the places. We have so many things. We have EC2s, we have lambdas, we have serverless solutions. We don't know what's the issue or when to look for the answer. And what is even worse, when things break, and we find a place that is broken, we don't know whether that's the source of issues or whether it's just a coincidence that something broke over there, right? So the complexity increased significantly. And we adapted to that. We adapted, now we do DevOps, we have infrastructure as code, we have many solutions that deal with serverless. However, when it comes to debugging our applications and dealing with databases, we do not have good solutions for that. When it comes to monitoring, we say that yes, metrics, monitoring, observability, that saves the day. The problem is when we look at like a typical architecture of some monitoring solution, it's even more complex than the stuff that we build, right? Just as plain, straightforward monitoring solution is as simple as you can see on this slide. So generally, tons of moving pieces, and all those things are interconnected and not very easy to understand. Yet another problem that we have is that when we want to debug stuff, And when we want to deal with metrics and with data to figure out what is going on, we end up with seeing dashboards like this one, right? How many times we saw dashboards that swamp us with raw data, with charts, with metrics, and they tell us, hey, your CPU spiked to 100%. Do you have an idea what's the reason? Is it a coincidence? Maybe some operating system update is being installed, or maybe there is a problem with your database, with indexes or whatever else. No matter whether you are Fortune 500 or small startup, we need to change that. We need to adapt to a new scenario in which we want to move faster, we want to push changes even faster than we are doing it today, but we don't have tools. And we need to have those tools, we need to have new processes, just like we learned that just deploying the stuff between developers and sysop managers is not efficient. And we need to have DevOps engineers, the same way we need to learn how to deal with databases, no matter whether it's SQL, NoSQL, or whatever else. And now, let's see what can actually break. So let's see which things can go wrong when we are talking about databases and how those things may affect our day-to-day work. So generally, when we are talking about databases, there are typically three important areas in which things may go wrong. So the first area is, well, code changes, right? So we implement a new logic in JavaScript, no matter what ORM we use, what library, what database we use. We generally need to implement like a new business feature, we need to implement new stuff, and therefore we run a different code after deploying to production, right? So we deploy to production, code is different, sends different queries to the database, and things go wrong. Okay? That's first area where things may break. Second area is about schema changes. So we want to change the like columns, data types. We want to add tables, drop tables, add indexes. This may result in various issues that are tied to like data quality, to the way we use indexes and other stuff. So for instance, we can add a new column and we have select star query that starts capturing this column. And due to that, we have an issue that now we extract much more data from the database, right? So this is the second part where things may break. But the third part, actually even worse, is what we call here query changes. But we are not talking about the query text has changed. We are talking that, hey, we have a code, the same code that it used to be for last 6 months, but now something has changed in the database. Index is not being used. Statistics are outdated. There is some maintenance task. Maybe we are now partitioning our database, sharding it, or whatever else. So nothing changed in the sense that our application was modified, but the query started executing differently. There is no index anymore that the code could use, so the query now gets much slower. So let's now talk about like various examples from all these areas and how they actually may kick us and how they break into this world. When it comes to things, how the schema changes may affect us, like whenever we add a new column, or whenever we change the column type, or whenever we drop a column, or do anything around the tables, we may affect how our ORMs, for instance, deal with data. Because you change the data type, now your ORM gets stuck or gets things wrong. Maybe previously it was reading integers, now it's serializing stuff to JSON. Things are getting slower and slower. And when you are dealing with heterogeneous applications, as we do in today's world, because we have microservices, one application is in JavaScript, yet another in TypeScript, yet another in Python, and so on, then different libraries that we use may read data completely differently. But for query changes, it gets even worse, because we deploy an index, and this index is useful today. But what happens 6 months from now, when we, for instance, start getting traffic from different countries around the planet? Our indexes may not be useful anymore, and we won't notice that, because those indexes are not reported kind of through our application, but through the database. We'll get to that in a second. ORMs. They introduce even more problems as we are dealing with our applications, because ORMs hide the complexity of our interactions with databases. They hide how we construct SQL queries, which indexes are being used, what's the default isolation level that we use, who commits a transaction, who rolls it back, who manages schemas, what triggers are being executed, stored procedures, views, partitions, and so on and so on. The problem with ORMs is that those tools are super helpful to get things done, but they hide from us how those things are done. And this is the issue. The issue with ORMs is that they hide this complexity, and when they get something wrong, then we are lost, and we have no idea how these things work behind the scenes. So those are generally aspects that may break with our current world today. No matter whether we are like Fortune 500 or small company or whatever else, we face those issues. And now we have three important aspects that we always want to focus on. First is preventing bad code from reaching production. Second thing is monitoring everything in databases, but focusing on the database, not like on CPU that it spiked to 100, but on the database that, hey, you deployed this stuff, it stopped using index, now your code is worse, slower, because the index is not useful, right? And third, most importantly, how we can fix those things and how we can do that automatically so that developers don't need to ask for help from like DB administrators or whatever else, but developers can finally own their databases. Their SQL databases, NoSQL databases, whatever other store they use, they need to own that. And when it comes to testing, because they tell us, hey, go with CI/CD, unit tests, integration tests, and you're all good, right? But when we look up on the, at the testing pyramid, what can go wrong when it comes to tests? Like unit tests, do we even check how we extract the data from the database? We do not. That is because unit tests then focus on the correctness of the data we extracted from the database, right? They don't check whether we use an index, whether we have n+1 problem from ORM or whatever else. They don't test it out. They only focus on the correctness. Same goes for integration or end-to-end tests. They generally verify that our application works correctly and does the right thing, but it doesn't check, those tests do not check whether our application does the things the right way. And we could at the same time argue, hey, apart from like unit tests and whatever else, we have load tests. So if there is a problem with indexes, with, I don't know, slow queries, with whatever else in our configuration, we have load tests, right? And they should capture it. The problem with load tests is they happen at the very end of our pipeline. After we implemented the code, merged it to the main branch, deployed to pre-production environment, this is when we run load tests, right? And this is far too late for us developers to be proactive and catch all the issues. Okay, so this is where we are now. This is how the environment, industry changed in the last years. Now the question is, what can we do with that? And the solution to that is database guardrails. So we would like to have a new process, new processes, new tools, completely new approach that will protect us from deploying bad code to production. And when things go wrong, those database guardrails will tell us, hey, this is how you fix that. So let's see how we can build those new solutions and how we can build database guardrails to get that. So the most important part to get successful database guardrails is we need to understand things focusing on databases, right? It's not that we just take metrics, hey, CPU 50%, or this amount of memory is being used. No, we need to actually go and see what's going on in databases. This is the crucial focal point of that. And how do we do that? Well, obviously, we could do that in production, as our slide says. But the idea here is we want to push all those checks to the left, as early as possible. So we can do that while we are developing the code. Let's see how we can do that. And generally, when we look at our industry, there are a couple of concepts that we can use. The first concept is called telemetry. So telemetry is this ability to collect the data. So we can collect signals like logs, traces, metrics, whatever else. And now we have good libraries for that. We have open standards for doing that. When we have telemetry, we can build the thing that is called visibility. So we can capture all the signals from all the places, right? No matter whether it's application code, Lambda, serverless architecture, queue, enterprise service bus, database, whatever else, load balancer, we can collect this data. Then what we think is enough is application performance management. So we build those dashboards, we build monitors, alarms, set thresholds, and that's it. However, that's not enough, because it swamps us with raw data, it just obfuscates us with data that is not actionable, and we don't know how to deal with that. What we need more is observability around databases. So the difference between monitoring and observability is that monitoring is about raw signals, and we don't know what to do with that. We really need to go and explicitly add thresholds, configure alarms, etc. Observability is about showing the story, telling us, this is what you deployed, this is the issue, this is how you fix that. That's the observability idea here. And in order to do that, we can obviously use two components. First is we can use OpenTelemetry. OpenTelemetry is like a open standard for capturing signals like logs, traces, metrics, and whatnot. And those open standards are delivered to our applications via SDKs. So we can install an SDK to our application, which is like npm install, and we are off we go. And this can capture things like those signals. And the way we can capture them, and what we can do with them is we can build things that are called traces and spans. So imagine that we have like this type of architecture. There is some load balancer. User comes and says, OK, I'd like to buy this ticket. Load balancer calls some web server, which calls some, I don't know, database, mailing mechanism, or whatever else. So generally, this is like a set of microservices doing the job together, OK? What OpenTelemetry lets us do is we can compose this trace showing us exactly what operations happened behind the scenes. And we can capture things like attributes of the operation, or human-readable explanation what was going on, timestamps, details, etc., etc. So this is what we do. We start with OpenTelemetry to capture those signals. Now, how do we turn that into database guardrails? What we need to do is we need to understand what we can observe. And to deal with databases, what we can do is we can see how queries are executed. So we take any database engine we have, whether it's Postgres, whether it's MySQL, whether it's NoSQL database like Mongo. Those queries, they typically go through various stages. And the important stage from all of those is called planning. So whenever you send a query that is called select star from table, such a query is first, the database engine plans how to execute the query. So what we can do is we can take a query like this one, whatever query, and we can prepend it with this explain keyword. And this explain keyword gives us this execution plan. And when we dissect this execution plan, we can see that it consists of various nodes, where each node represents a single operation. For instance, like sequential scan of the table, or maybe scan of an index, right, of bitmap index scan, or maybe some loop join. So generally, all those nodes, they show us how queries are executed. And the important part with those queries is that every node has cost associated with it. And this cost tells us how hard it is to execute a given query, a given operation. This cost can basically tell us whether we can generate multiple plans and then choose the cheapest one. And this is the idea that we can use to build database guardrails. We can use OpenTelemetry to instrument our applications, and then we can capture those execution plans, see what is going in the database, and then compare that with how it would work in the production database. So then without leaving our developer environment, without leaving Visual Studio Code, nothing like this, we can immediately tell whether such a query is going to work well in production or whether it's going to be too slow. And this is what we can do. So generally, the idea with database guardrails is we would like to prevent the bad code from reaching production, and now we have tools for doing that. We have OpenTelemetry, we know how SQL queries are executed, we know how to get execution plans by using explain keyword, and we can capture all of the data. Then we can monitor the stuff. We can build the monitoring around our databases, showing us that, hey, this is the query that you were executing, and this query stopped using an index. It was using an index a week ago, now it's not. That's probably the reason why the query is so slow. And when we connect that with our CI/CD, GitHub Actions, or whatever else, then we can analyze how things were changing. And finally, we can do automated troubleshooting. We can say that, hey, this is what you changed, your index is not being used anymore, maybe change the index, maybe configure it. So this is the idea of successful database guardrails. And the idea to use it is we need to be proactive, and we need to let developers own their databases and push those checks to the left. No matter whether you are a small company, big company, whether you are dealing with like mature product or maybe something completely new, we need to have those database guardrails, and we need to have them now. That's the idea, because we can't wait for others to maintain our databases. We as developers need to own our databases and need to finally take ownership of everything that happens. And Metis does exactly that. Really quickly, we integrate with those stuff, we integrate with your code, CI/CD, whatever else. We provide database observability, focusing all that stuff. We have a booth over there. Feel free to come, ask around. We are going to show you all that you would like to know. Being all of that said, databases, they really break in today's world. We push changes as fast as possible. We implement Jira stories faster than ever. And we don't own our databases. We need to change that. We need to be proactive. We need to push all the checks to the left. We need to have database-focused monitoring and observability. And we need to integrate all our layers of software development lifecycle to make it work. And this is how we need and why we need database guardrails. And being all of that said, I'd like to thank you for coming here. If you happen to have any questions, I'm happy to answer them.